Here's a circuit I came up with to test the digital pot in real-world applications, not just controlling it and measuring its resistance without being in use. So there's three sections to this. I'm using a 555 as an oscillator, and it can go between 280 Hertz to 3 kilohertz. And it has a 100K pot as part of its timing circuit, along with some other standard values that I have around. And the duty cycle is very high with a short off period at whatever frequency my pot is set for. And because ultimately I'm going to use an op amp as a signal conditioner, because I'm using this to simulate if I had a sensor or transducer or something like that I want to ultimately do signal conditioning and pretend I'm going to bring it into some analog to digital converter. I didn't just want a digital on-off signal, I wanted something with a bit of a waveform shape to it. So I added a little RC circuit here, so my square waves will have a little bit of rounding. So I'm charging up, staying on for a lot, and then quickly discharging at a bit of a slope and charging up again at a slope, staying on. So I'm creating these sawtooth looking things. So then I have a second 100K pot that I want to use to be able to attenuate this. Everything's running on 5 volts from the Arduino, and the digital pot is only 5 volt tolerant. So it all makes sense to keep the whole system at 5 volts so everything's safe. So I have this second 100K pot that I'm using to attenuate this 5 volt square wave down to whatever I want, toward 0 volts. So the wiper of the pot is going to go into an op amp, and depending where the wiper is, I'm either going to get my full strength signal or gradually changing the amplitude lower and lower until I have 0 input. So what I want to do is take a signal, turn it into a little bit of a shape that I can look at instead of just square wave on and off, be able to attenuate it down into the millivolt range, and then use an op amp to signal condition it back up and pretend I took a weak signal from a sensor and I'm going to go into some microcontroller analog input. So in order to do this, to be able to scale the signal back up, I have a 351 op amp, and I have it configured with a gain that I can set up to 10 times. Again, using a 100K pot in the feedback loop and a 10K on the input. Because we're running a single supply, I have to bias the input up, and normally you do that by setting it halfway to your supply. But this isn't a rail-to-rail op amp, and I think the maximum output with a 5 volt supply is going to be 4.5, so this is not an exact 50% voltage divider. I don't even know what values I used. I just played around with it so that I wouldn't get distortion. So it's just to have some sort of a reference voltage here to get the signal to swing around an offset. And it is an inverting configuration, so these little fins are going to be flipped around, so we have mostly a low and then the occasional little spike with the gain as we set with our pot. Using this 555 A-stable circuit calculator from the Ohm's Law calculator website, my capacitor is 47 nano. My resistor 1 up here is my 100K pot, and then the resistor 2 is a fixed 4.7K resistor. So with these values, if we have the pot set for 100K, our frequency is 280 Hertz. And our duty cycle, it's 95%. It's almost always high, and then it dips low for the rest of it, then it goes back to high. So, as we change the resistance on the pot, say we put it down to 1K, now our frequency is just about 3 kilohertz. For the op amp, in the feedback loop, I have this configuration, and I put an offset here because I have a single polarity supply, not a split supply. The feedback resistor is where I put my 100K pot, and my input resistor is where I put a fixed 10K resistor. And when we have the pot set for 100K, we get a gain of 10. And of course, as we turn down the pot, our gain's going to drop. So you can attenuate this all the way down to nothing or get the full 10 times gain. As usual, everything's a mess and it's hard to get everything in frame at once, so let's pan through. We still have here the digital pot from the previous video I'll link below. So the Arduino is controlling the digital pot and there's all those push buttons to run it. And now we have the new op-amp circuit with the 555 oscillator simulating a small voltage sensor or transducer that we're signal conditioning with the op-amp. So on the little white breadboard, on the left is the 555, and then it goes through the RC circuit to do some wave shaping, and ultimately it goes to the op-amp on the right. I have 3 potentiometers on the red Lego breadboards. The one on the left controls the frequency of the 555. The one in the middle controls the overall amplitude from max to ground of the 555 signal, which goes into the op-amp from there. And the gain of the op-amp from 0 to 10 times is controlled by the pot on the right. Then there's scope probes attached and the scope. So we're going to work backwards through the circuit. For now, let's just look at the yellow trace as our input to the op-amp, and we're going to pretend it's some sort of sensor signal that we need to properly condition. So it's at just over 500 Hertz, and it's peak-to-peak amplitude. By the way, I put this on AC coupled mode, so there are DC offsets, but I wanted to compare the wave shape itself. So peak to peak on the input, it's about 250 millivolts, which is relatively small compared to having a 5 volt or 4.5 volt op-amp swing. So let's say we wanted to take this 250 millivolt signal and we're going to go to an analog to digital input on a controller, and we want it to be at 1 volt peak to peak. So we need some gain on this signal. The blue output op-amp trace, currently it's at 700 millivolts. So we would want to adjust the gain pot over here until we get 1 volt peak to peak. So I'm turning it up. So now we can see the output waveform got larger. The input is still 250 millivolts, and now the output with the gain is 1 volt peak to peak. Now let's say that this board that we have here, this signal conditioner board, we don't want to build a different board for every kind of sensor. We have different sensors. Some will have 250 millivolts. Some are going to have maybe 450 millivolts or whatever. Or even sensor to sensor. We plug in the exact same type, but one is 250 millivolts. The next one might have an offset and it's 270 millivolts. But we want the maximum to always be 1 volt. So we need some way to tweak this without having to have a very custom board for every single thing we're going to plug in. And let's say it's not really convenient to have a potentiometer that we have to adjust. It would be nice if we could do it remotely over Wi-Fi or something like that. Let's just go with that as our requirement. But in the meantime, so we're set up with a 250 millivolt signal. We've scaled it with our op-amp to get 1 volt out, but now let's say we plug in a different sensor altogether and we want to use this same board and we want to have 1 volt out. Let's say it's a 450 millivolt new sensor signal. So let me adjust my attenuator on the input of the op-amp. I'm going to allow more of the 555 test signal through. So I've adjusted it to about 450 millivolts of an input sensor signal. And now, of course, it's a stronger signal, so our gain is going to be applied to this, and now we got 1.79 or 7 something. We want this to be scaled again to just 1 volt to suit our particular needs. So again, we have to adjust the gain on the op-amp to get 1 volt. So we turn down the gain. Now, we have our new signal around 450 millivolts going in, and we have 1 volt going out. Well, let's see if we can do this with a digital pot. So with this mess here being the Arduino controlled digital pot, I've got the 3 potentiometer wires right here coming out of that. Let's replace the gain pot on the op-amp with the digital pot. Okay, I've plugged in the digital pot to the little Lego breadboard that the old gain pot used to be on. Here's all of our control buttons for the digital pot. So right now the gain is so high it went off the scale. So I'm going to use the up and down by 10% buttons on the digital pot. So I need to turn the gain down. Now I'm only using 2 terminals of the pot here, and I don't know if I connected it to the low or the high digital pot terminal, so up and down are meaningless. I'm just going to try both until it works. So it looks like I have to go with this button to change it by 10%. So the gain is, oh, we're in range. So I have 450 millivolts in and I want 1 volt out. So right now I have 1.8 volts out. So I have to scale this down further with the digital pot. 1.35, 900 and something, just over 900. So now I'm going to use the 1% buttons. So I need to go back up. I'm pushing the button. Oh, there it is. Let me see if I can zoom in. About 450 millivolts in, 1 volt out, controlled by a digital 100K pot. So instead of a physical 100K gain pot on the op amp, we can use the digital pot and either have software physical buttons to adjust it, or we can be remote and do it over wireless or the internet, or we could have a software algorithm that just reads the analog input. You can put maybe the input in a test mode, so you're calibrating it and you read it until you only have 1 volt maximum ever and you know you're at the right gain. Then you put the circuit back in operation, all just automatic software. So that's one use for a digital pot. Now let's take that op amp portion out of the equation and look at the 555 itself for 2 more applications of a digital pot. Now I have this little audio amplifier with a couple of alligator clips coming down to the circuit with the op amp removed from the whole equation. Now there's only 2 pots, 555 frequency and the volume. Basically it's going to be now because we're using it as a tone generator. So this is all gone now. We have the 555 generating 280 hertz to 3 kilohertz. We go through still the wave shaping circuit, but then we have this potentiometer here, which is essentially, that's where I plugged in the audio amplifier. So this is a volume control going in. We can turn the wiper all the way to the signal for full volume or all the way to ground for quiet. So the yellow trace is our 555 oscillator. It's still at 515 hertz. And the blue trace is the output of that volume control potentiometer, currently set to ground, so it's 0 signal. If I turn up the volume pot, we'll hear the tone. So now, let's see if we can get the digital potentiometer to act as a digital volume control. Okay, so I plugged in the digital pot 3 wires here from the Arduino circuit into where it comes out of the 555 and then goes to the wiper or to ground, and that goes to the audio amplifier. So again, I don't know which end of the wiper is high or low on the digital pot, so up or down buttons are just going to have to be messed with. Right now it's set for 0 volume, meaning the wiper is set toward full ground. So digital pot as a volume control. That has much more intuitive uses. You just can have digital push buttons and turn the volume up and down without having something like this. And also, if you want a circuit itself to be able to control the volume, rather than you want to manually turn it up or down, you can have control like that. Now let's look at controlling the frequency of the oscillator. So we only need 1 channel now. We're just looking at the 555 output after the RC filter. So if I start the pot up at the middle level, I get 444 hertz, and I can go up and down by the 10% buttons, and I can get a few different tones, and then I can actually fine-tune it with the 1% buttons. 1.4 kilohertz, all the way down to 242 hertz, which I think would be just the wiper resistance. So let's go up with 1%. I get a lot of control down in the low frequencies. Let's skip up toward the higher and then try to fine tune it. 1.4 kilohertz, 2.7 kilohertz, and then it cuts off. So I can get my, well, 280 hertz up to 2.7 kilohertz as designed using a digital 100K pot. So you could program in melodies and have it change the pitch, or if you want to rewrite the code, you can just try to create some sound effects by changing the pot strategically. In order to try generating different sound effects out of the 555 oscillator, where I'm using this 100K digital pot as the frequency control, I modified my original program from the last video and made a little note here that this version is for controlling the 555. I renamed the buttons to just generic 1 through 7 instead of going up or down by 1 or 10 steps, etc. And then, depending which button is pressed, I temporarily stay in a loop to generate a certain sound effect, and then we're done and we just wait for another button press. So one button does a two-tone siren. All I'm doing is setting the pot at a certain position relatively to one end of the wiper range and letting it go for a certain amount of time to generate one tone. Then I move the pot toward the other end of the wiper range, generating a second tone, and wait again. So if you go back and forth with low and high tones, it's like a siren. Then I did a sliding up and down tone siren, and I'm using the trim pot function, so I'm just moving the wiper one position from where it last was in the up direction and then back in the down direction for a count between 1 and 50. So I go 50 steps up, 50 steps down, and that's a sliding siren. Then I called this a laser shot. What I'm doing here is I'm starting with the potentiometer relatively to one side, and then I relatively quickly adjust the pot by one level going toward the other direction on the pot, and then I continue on going through the rest of the pot range but at a slightly slower rate. So it starts out quick, sliding the tone, and then it slows down a bit to finish off sliding the tone. Then just random bleeps and bloops. I just randomize a number between 1 and 98, so not the extreme 0 and 99 ends of the pot, but to guarantee I get some resistance. And I just play whatever tone that is by setting the wiper to that position and changing the resistance, which changes the frequency on the 555. And then I just wait a bit, generate another tone. I do this for a count of 0 to 40. So if I kind of do the same thing, but do it much faster, less delay between notes, and then do it for way more notes because I'm doing it so quickly, generating a bunch of random sounds is kind of like a noise generator, but it's not going to be white noise because we only have so many frequencies we can get with our current oscillator, so it's colored noise. And then the other two buttons are just miscellaneous effects. All I did is I took snippets from these other things, sliding effects and random bleeps and bloops, and I just made up some stuff, doing a bunch of delays in a row and generating weirdness. So here's all the buttons, and they've been reprogrammed to make sound effects out of the 555 being controlled by the digital pot, where the wiper is sliding all over the place based on what button we press. And I still have the scope hooked up, so let's see. We start with a two-tone siren, and then a sliding siren, a laser shot, and noise and bleeps and bloops. Okay, so there's a few things you can do with a digital pot. Just some ideas on the kind of things that are possible. Just another tool to have in the toolbox.